This is question number 4 on the 3.4 related rates worksheet. A spherical balloon is inflated at a rate of 27 pi square inches or cubic inches per second. Okay, so this right here should be per second. How fast is the radius of the balloon increasing when the radius is 3 inches? So I'm going to first of all start off with dv dt equaling 27 pi, and then you want to find dr dt when the radius is equal to 3. So I'll first of all start off with the volume formula for a sphere, which is 4 pi over 3 and then r cubed. So I take the derivative, so that would be dv dt is equal to 4 pi r squared dr dt. And then I'm going to substitute in for dv dt, 27 pi is equal to 4 pi, and then the radius is equal to 3, so then that would be 3 squared, so that's 9, and then dr dt. So simplify all this and divide through, and the pi's will cancel out, and 27 over 36 will reduce to 3/4. So the unit for the radius is inches, and the unit for time is seconds. So that will be 3/4 inches per second. Question 5. Car A and B leave a town at the same time. Car A heads due south at a rate of 80 kilometers per hour, and car B heads due west at a rate of 60 kilometers per hour. How fast is the distance between the two cars increasing after 3 hours? So here is my diagram, and here is car A and car B that are leaving at the same time. So car A is heading south, and then car B is heading west. So dA dt, which is the car A's rate, is going to be 80 kilometers per hour, so that will be 80. And then car B has a rate of 60 kilometers per hour, so that's dB dt, and that's 60. And then how fast is the distance between the two cars increasing would be the dC dt, and that's when t is equal to 3. So I'm going to first of all look at what is the distance going to be for each of the cars. So the distance formula is rate times time. So the distance for car A is going to equal 80 times 3, so that will be 240. The distance for car B is 60 times 3, and that is 180. And then for car C, I'm going to use the distance between car A and B. So I'm going to use a Pythagorean theorem, which is a squared plus b squared is equal to c squared. So 240 squared plus 180 squared is equal to c squared. And so c comes out to 300. Okay, so now I'm going to take the derivative using implicit differentiation. So I have a squared plus b squared is equal to c squared. Now, all of these are going to be changing, so I cannot substitute in any values before I take the derivative. So 2a dA dt plus 2b dB dt is equal to 2c dC dt. So I'm going to cancel out all of my 2's, cancel this, this, and this, and then I end up with a dA dt plus b dB dt is equal to c dC dt. Okay, now I'll substitute in all of the values. So a is equal to 240. dA dt is equal to 80, b is equal to 180, and dB dt is equal to 60, c is equal to 300, and dC dt is what I want to find. So then simplify all of this, and you end up with dC dt equaling 100 kilometers per hour. Question number 6. A cylindrical tank with a radius of 6 meters is filling with fluid at a rate of 108 pi cubic meters per second. How fast is the height increasing? So I'm going to first of all start off with the volume of a cylinder, which is pi r squared h. Now in this problem, the radius is a constant because in a cylinder, unlike a cone, as you fill it up with fluid, the radius stays the same. So they say that the radius is equal to 6 meters. So I can just substitute in R is equal to 6 and just write the formula as volume is equal to 36 pi h. dV dt is given as 108 pi, so then I just need to find dH dt. So taking this derivative with respect to time, dV dt is equal to 36 pi dH dt. So substitute in dV dt, which is 108 pi, is equal to 36 pi dH dt. Divide through, the pi's cancel out, and 108 divided by 36 gives me 3. So dH dt is equal to 3 meters per second. Question number 7. The sides of an equilateral triangle are increasing at the rate of 27 inches per second. How fast is the triangle's area increasing when the sides of the triangle are each 18 inches long? So I'll start off with the formula for an equilateral triangle, which is equal to square root of 3 over 4 times side squared. And then the information for 37 inches per second is the side's rate of change, so that will be ds dt, and that is 27. And then the question is asking what is dA dt when the side is equal to 18. So taking this derivative, I have dA dt is equal to, bring down the 2, so that's square root of 3 over 2 times s times ds dt. So then dA dt is equal to the square root of 3 over 2, and s is going to be 18, and ds dt is 27. So putting all of that together, I get dA dt is equal to 243 times the square root of 3, and for area it would be square inches, and for time it's going to be seconds.